For today's lesson, we will be discussing about the formula that will help us determine the appropriate number of sample. And this formula is called the Slovin's Formula. So before we proceed to our main topic, let's first recall the difference between population and sample. Again, population is the total set of observations that can be made, and it is denoted by the letter or uppercase N. And a sample, on the other hand, is just a subgroup of the population, and it is denoted by lowercase n. Now remember that you have also learned that when we are using a sample, there will always be an error. And that is called the margin of error. It tells you how many percentage points your results will differ from the real population value. Now, the margin of error can be used in determining the appropriate sample size that we can select from a certain population. Now, what is the importance of the Slovin's formula? When it is not possible to study an entire population, such as the population of the Philippines, for example, a smaller sample is taken using a sampling technique. Slovin's formula provides the sample size using the known population size and the acceptable error value. Now, the Slovin's formula allows a researcher to sample the population with a desired degree of accuracy. It also gives the researcher an idea of how large the sample size needs to be to ensure a reasonable accuracy of results. Now, how can we use the Slovin's formula in finding or determining the sample size? Again, to compute the sample size, the Slovin's formula is used. And the Slovin's formula is n is equal to uppercase N all over 1 plus NE squared, where lowercase n again is the sample size, uppercase N is the number of cases or the population, and E is the margin of error. Now, let's apply that formula in finding or determining the sample size. For example 1, a researcher wants to know the average income of the families living in Barangay A, which has 2,500 residents. Now we have to calculate the sample size that the researcher will need if a 5% margin of error is allowed. Again, let's use the formula or Slovin's formula, n is equal to n over 1 plus NE squared. Now let's plug in the values. Again, we're looking for lowercase n or the sample size. So we have uppercase N or the population is 2,500 because Barangay A has 2,500 residents. Over 1 is constant plus, again, uppercase N is 2,500 times the 5% margin of error must be converted into its decimal form. So 5% is equal to 0.05. So we have 0.05 squared. Let's first evaluate 0.05 squared, and that is equal to 0.0025. Now let's multiply 2,500 times 0.0025, and that is equal to 6.25. Then 6.25 plus 1, that is 7.25. Now we have 2,500 divided by 7.25, that is equal to 344.83. But since we're talking about residents, we're talking about people, we have to round it off to its nearest whole number. So 344.83 is approximately equal to 345. So that is the sample size wherein 5% margin of error is allowed. So that is how you apply the Slovin's formula in finding or determining the sample size. And as you can see, Barangay A doesn't have a group or is not divided into sections or parts or groups. Therefore, this is just simple random sampling. The next one, for example 2, we have, suppose a researcher wants to determine the average income of the families in a barangay having 3,000 families that are distributed in 5 streets. Now we have to compute for the sample size n at 5% margin of error. Now as you can see in the problem, the barangay is divided into 5 streets, having 3,000 families in total. Now, obviously, that is stratified random sampling because we want each street of the barangay to be represented in the study. Now, how can we apply the Slovin's formula in stratified random sampling? How can we apply it in determining the sample size from each street of the barangay with respect to its population? Remember that our first step is to first determine the total number of sample that we can get from the 3,000 families. So we can apply the Slovin's formula in finding the total sample size. So we will use our population as 3,000 or the population of the whole barangay. So we have 3,000 over 1 plus 3,000 times, again, 5% margin of error. So we have 0.05 squared. And again, that is 0.0025 times 3,000, that is 7.5. Now we have 1 plus 7.5, that is 8.5. So to get the sample size, we have 3,000 over 8.5. And that is equal to 352.94. Again, we're talking about people, so we have to round it off to its nearest whole number. And that is approximately equal to 353. Now that we have already determined the total number of sample size or the total sample size, how can we now get the sample size from each street? Now let's say that in street 1 we have 800 people. In street 2 we have 400. In street 3 we have 500. In street 4 we have 600 people, and in street 5 we have 700 with a total of 3,000 as the barangay's population. Now how can we divide 353, which is the total of sample size, into 5 streets, again with respect to their population? Now as you can see in our table, we have to get the percentage first. Now how are we going to do that? Again, we have to get the percentage so we can get or determine the sample size for each street with respect to its population. Now, how can we get the percentage? Let's first get the percentage of 800 or for street 1. For us to get the percentage, we have to divide the population for that street by the total population. So we have 800 divided by 3,000, that is equal to 0.27 or 27%. And then do the same for the rest of the streets. We have 400 divided by 3,000, that is equal to 0.13 or 13%. Next, 500 divided by 3,000, that is 0.17 or 17%. 600 divided by 3,000, that is 0.2 or 20%. And lastly, we have 700 divided by 3,000, that is 0.23 or 23%, with a total of 100%. Now again, our first step is to determine the percentage of each street or the population of each street. Now that we have the percentage, we can now determine the sample size for each street with respect to its population. Now, how can we get lowercase n or sample size for street 1? Our next step is to multiply the percentage for street 1 by the total sample size, which is 353. So we have 0.27 times 353. Again, to get the sample size for street 1. Don't forget to convert the percentage into its decimal form. So 27% will become 0.27 times 353, that is equal to 95. Again, we're talking about people or families, so don't forget to round off your answer to its nearest whole number. Next, we have 0.13 times 353, that is equal to 46. Next, 0.17 times 353 for street 3, we have 60. For street 4, we have 0.20 times 353, that is equal to 71. And lastly, we have, for street 5, we have 0.23 times 353, that is equal to 81. Now, as you can see in our last column, we have now determined all of the sample size for each street of the barangay. So for street 1, we can get 95. For street 2, we can get 46. For street 3, we can get 60 families. For street 4, we can get 71. And for street 5, we can get 81. That's a total of 353 families for our sample size. Again, at 5% margin of error. So that is how you apply the Slovin's formula to determine the sample size with stratified random sampling.